Solve the following equation. The square root of 1 minus x plus 1 is equal to the square root of 6 minus x. Since we have two square roots and another term that does not have a square root in it, then I cannot get rid of both of the square roots at the same time. So since one of them is isolated, then by squaring both sides, I will remove the one square root that's being isolated, but this side will still have a square root. So on this side, I need to actually write two sets of the square root of 1 minus x plus 1, and I need to multiply it by itself, since you can't distribute your square across this plus. So I have two sets of that need to be multiplied out. But on the right hand side, since there's only one square root and I'm squaring it, then I get 6 minus x. So distributing this out, the square root here times the square root here will give me 1 minus x. But the outsides will give me one of these square roots, and the inside will give me another one of those square roots. So adding those, I have two of the square roots, which are 1 minus x. And then my last is 1 times 1. So now looking at the problem, you see that I went from 2 square roots down to 1 square root. So at this point, my goal is to isolate this square root so I can square both sides. So if you notice, you have a negative x on both sides, so those will cancel. So I add my like terms to give me 2 plus 2 times the square root of 1 minus x equals, and there's only 6 left on this side. So subtracting 2 from both sides gives me 2 times the square root of 1 minus x equals 4. And I'll go ahead and make the problem smaller by dividing both sides by 2, giving me the square root of 1 minus x is equal to 2. Finally, I'll square both sides again to get rid of the second square root. So this gives me 1 minus x is equal to 4. And then I'll subtract 1 from both sides. So negative x must equal 3. Therefore, x must equal negative 3. Now, we need to check that this is really the answer, because we have two square roots. So back in the original problem, I'll use x is negative 3. So we have the square root of 1 minus a negative 3, and then we're adding 1. Let me make sure that that square root doesn't go over the 1, and this needs to be equal to 6 minus a negative 3, all in my square root. So here I have 4. Square root of 4 is 2. 2 plus 1 equals, and here I have 6 minus a negative 3, which becomes plus 3, so that's 9. And so this is a true statement. 3 does equal 3. Therefore, x really does equal negative 3.